If we want to talk about linear programming, the first thing we need to do is we need to define a feasible region and then understand what an objective function is. A feasible region is a region on a graph that is created by graphing a system of inequalities. So, for example, if we had a system of inequalities that might include this line, and this line, and we saw that this created this region in here, this is called a feasible region. Now, it is important to note that the points of intersection, these points here are called corner points. And that's going to come into play. That's going to be important for solving linear programming applications as well. Now, this kind of region is what is known as a bounded region because, as you can see, it is bounded on all sides of the region. And sometimes a bounded region can have 3 lines that bound it. Sometimes it can have 5 lines that bound it. It just depends on what the particular inequalities themselves are. But sometimes we can have a region that maybe looks like this inequality, and this inequality. And when we graph it, we end up with a region that looks like this. This region still has corner points here and here, but this is what is known as an unbounded region. So those are the 2 different types of feasible regions that you're going to see. Now, one more thing that it's important to mention, these inequalities here that are bounding our regions, there's a whole bunch of them, right, in these particular problems, these are all called constraints. So we have our constraints, we have our corner points, and we have either a bounded region or we have an unbounded region. Now let's talk about our objective function. Our objective function is the function for which we are trying to find a minimum or maximum value in the feasible region. What that means is, if this is my feasible region here, so let me draw another feasible region. Let's say this is my feasible region. And in this case, there will be 4 constraints. So this is my feasible region, and I have my 1, 2, 3, 4 corner points. The question that we're going to have is this particular function we're talking about, this f of x and y, it's going to be some linear function of x and y. When we look at it in relation to this particular feasible region, where is this greatest or smallest? Again, some problems are going to be maximum problems, some problems are going to be minimum problems, meaning if I take this point here in the region, right, that's an xy, and I plug it into my function, it's going to give me a value. If I take this point here and I plug it into my function, it will give me a value as well. It's going to give me some number, right, when I plug those in. And the question is which of these points in this region gives me either the maximum value or gives me the minimum value? Now, one last thing to keep in mind, if we have an unbounded region, so again, let's say this is our unbounded region. An unbounded region is not going to have, this particular type is not going to have a maximum value. In the same way that if my region were to look like this and it was an unbounded region, it would not have a minimum value. So you cannot tell for sure whether an unbounded region will have a max or min. It depends on what direction it is going. If it's going up, it's not going to have a maximum value. If it's going down, it's not going to have a minimum value. The last thing we need to talk about is the corner point theorem, and it tells us that if we have our feasible region, our objective function will attain its max or min at one of the corner points. So in this particular example, if we take all 4 corner points and we plug them in, we are going to find our max or our min there. And what that means basically is that all of these other points in the region, they are all irrelevant. We only care about the corner points in order to find the maximum or the minimum.